All right, Algebra 2 students, we are moving on to section 2.6, and this is all about the quadratic formula. So our learning target for today is I can solve a quadratic equation using the quadratic formula. So last section we talked about quadratic equations and we learned how to solve them using factoring. So factoring is a very good method for solving quadratic equations, but sometimes a quadratic equation is not factorable. So in those cases, we can use the quadratic formula. The quadratic formula works every time. So let's look at this quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we're talking about these a, b's, and c's, they're taken from the standard form. So here's your standard form. Ax squared plus bx plus c equals 0. So the a is the coefficient of the x squared term, the b is the coefficient of the x term, and the c is that constant by itself there. So when you're given a quadratic equation, so let's look at this example right here, 3x squared minus 4x minus 9 equals 0. When you're given this quadratic equation, the first thing you want to do is make sure it's in standard form. Is it in order? Do I have my x squared, my x, my constant equals 0? Yes, I do. So that's step one. Always make sure the equation is in standard form. All right. So once we do that very important step, now we can move on to the next part of our success criteria. So I've determined this is in standard form, and now I can label my A, B, and C. All right, so write the quadratic formula. We have that up here, so we'll refer to that. Keep that in mind. But now I need to determine my A, B, and C. Very important. All right, so let's look at our example here. 3 is my A, negative 4 is my B, and my C is negative 9. So we have A, B, C. And if there's no number written in front of the x squared or the x, then that's a 1. You would just call it a 1. And if there's no c term, then you would call it 0. All right, so I have my standard form. I have my a, b, and c. Now I'm ready to substitute a, b, and c into my quadratic formula. So here's my quadratic formula. Now I'm going to replace the a, b, and c with my numbers from up here. And that is substituting, okay? Got my quadratic formula. Now I'm ready to substitute. So negative b, so negative 4 plus or minus square root b squared, so negative 4 squared minus 4ac, a is 3, c is negative 9, all over 2a, 2 times 3. Okay, now we're ready. Now we've did our substitution. Now we're ready to go to this next step, simplify. Now take your time on this and really go through each step carefully. So my first step of simplifying is to evaluate the discriminant. We'll talk more about what the uses of the discriminant is, but for now just know that the discriminant is what is inside the square root here. Just the b squared minus 4ac part. So I'm going to simplify that first. So simplifying in there, follow the order of operations. So order of operations says do your exponent first. So I'm going to do this negative 4 squared first. Negative 4 squared, or negative 4 times negative 4, is 16. And then I'll do my multiplication here. So I'm going to do negative 4 times 3, which is negative 12, and then negative 12 times negative 9, which is positive 108. All right, now remember, I'm trying to simplify in here. I'm simplifying in here. So now I'm going to do 16 plus 108, which is 124. And then I can take care of these right here. So a negative 4, negative times a negative is a positive, so that turns to positive 4. And then 2 times 3 on the bottom is 6. All right, we've got it down pretty far. We've evaluated the discriminant. We've taken care of these other simplifying. Now we can go to step 2 of our simplifying, which is simplify the radical. We learned how to do this last section. So my radical is the square root of 124. So to simplify that radical, remember first we make a factor tree. So break down that 124. I'm going to do 4 times 31. And then I can keep going with that 4. 2 times 2, which is a pair, so I'm going to circle it. 31 is prime, so that's done. So remember, pairs come out and singles stay in. So my pair of 2's will come out of my square root, and my single 31 is going to stay in. And now my radical is simplified. At this point, you want to see if you can reduce it all. So remember, I'm looking at these numbers here, 4, 2, and 6. Those can be reduced by 2. So let's just make a little note here. After we simplify the radical, reduce if possible. Okay. So I'm going to reduce by 2. 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 6 3 times. And then I have 2 plus or minus the square root of 31 over 3. And I'm going to leave it like that because in this radical form, I'm going to get an exact answer. If I put this in the calculator, I'll get a decimal answer. So I'm going to go ahead and leave this here so it's very accurate. But you'll see down when we do B, these 2 steps will come into play. So hold off on that. We're going to get into this in our next example here. All right, so remember, make sure it's in standard form. That's our first step of success criteria. So squared, x, constant, 0. We're good. Now, step 2, make sure you label your A, B, and C. A, B, C. So A is 2, B is negative 11, and C is 12. Now we're ready to substitute in those values for A, B, and C into the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Plug them in. Negative 11 plus or minus square root b squared minus 4ac all over 2 times a, which is 2. All right, substituting done. Now we got to dive into the simplifying. So we're going to start with our discriminant. Discriminant is what is inside the radical here. I'm going to start with that. And along the way, I can take care of some of these easy simplifying. So negative times a negative is a positive. And then, of course, 2 times 2 is 4. All right, so let's dive into here, the discriminant. When you're working on the discriminant, do the exponents first. So negative 11 squared is negative 11 times negative 11, which is 121. And then I'm going to do my multiplication here. So negative 4 times 2 is negative 8. And then negative 8 times 12 is negative 96. Now I'm going to go ahead and take care of that subtraction. I'm working on finding my discriminant here. So 121 minus 96. 121 minus 96 is 25. All right. Now I'm ready to simplify my radical. So that's the second step of simplifying. So we found the discriminant. We took care of the other simplifying. Now we're ready to simplify the radical. So square root of 25, that's an easy one. That's a perfect square. Square root of 25 is 5. So then my radical is simplified. Now, I'm going to pull this back up for a minute here. Now we can do, since the radical is gone, we could go ahead and go to step 3 of the simplifying. Add or subtract the numerator. Why is it add / subtract? How do you know which one to do? Well, look down here. When you take the square root, there's 2 possibilities. It could either be positive 5 or negative 5. So you have to take each case. So let's start with the adding one. So I'm going to do 11 plus 5, which is 16, and then divided by 4. And then that's where this step comes in, divide. So I can do 16 divided by 4, that is 4. All right, so that's my first answer. Now I need to take the subtraction part. So I just did the adding, 11 plus 5 is 16. That's where that came from. Now I'm going to do the subtraction. So 11 minus 5 is 6, and then divide that by 4. And then that can be reduced by 2, so that reduces down to 3 over 2. And then those would be your answers there. All right, let's look at one more. Now this next one is going to be very fun because we're going to end up with an imaginary number. So if you remember back to last section, whenever you have a negative inside of a square root, you have to turn it into an imaginary number. And we're going to see that in this example here coming up. Still, you do it the same way. Check for standard form. X squared, x, constant, 0. We're good to go. Now we're going to label our A, B, and C. A, remember I said earlier, if there's no number in front of the variable, you assume it's 1. So A is 1, B is -9, and C is 27. All right, now we're ready to plug them in to our quadratic formula. So negative b plus or minus the square root, b squared minus 4ac all over 2a. Now we can get to simplifying. I'm going to take care of these easy ones first. So negative, negative, that turns to positive. And then 2 times 1 is 2. Now I'm going to dive into this discriminant. So remember, always do exponent first. So -9 squared is 81. And then I'm going to do 4, negative 4 times 1 is negative 4. Negative 4 times 27 is negative 108. Take care of that subtraction. So 81 minus 108 is negative 27 over 2. Now, look at this. We have the square root of a negative number. So this right here, square root of negative 27 is the square root of 27i. So we're going to go ahead and write that in the complex form. Now we can simplify the square root of 27. So let's just take a look back at this success criteria before we get ahead of ourselves here. So what did we do? We found the discriminant, and now we're down to here, simplify the radical. So I can simplify the square root of 27, and that's what I'm going to do right now. So I'm going to pull this 27 aside, and I'm going to make my factor tree 3 times 9, break down my 9 to 3 times 3. There's my pair. So x equals 9 plus or minus, pairs go out, singles stay in. Don't forget your I there, all over 2. Now remember last section we talked about how complex numbers need to be in standard form. So standard form is a plus bi. A is my real number, and then the bi is my imaginary number. So my real number would be 9 over 2 plus or minus. Then I have 3 square root of 3 over 2i. And that's my final answer. That's as far as I can go. I can check to see if I can reduce anything. So I can't reduce 9 over 2. I can't reduce the 3 and 2. So we're in the simplest form. And then that would be your final answer right here. 9 over 2 plus or minus 3 square root 3 over 2i. All right, those are all the examples we're going to do today. Tomorrow we'll look at a couple more, and we'll look at some applications of the quadratic formula. But for now, you're just going to practice solving equations, solving these quadratics using the formula.